start in the name of Allah, the most gracious and the most merciful. Assalamu alaikum, dear students. Unit number 2, real and complex numbers. Before I move on to the exercises, I would like to present before you some of the terms and definitions used in the upcoming exercises of this unit. Once you have a clear understanding of these terms, you can easily tackle exercise 2.1 and 2.2, which are mainly of objective based. In a decimal number system, there are only 10 numbers, that is from 0 to 9, and these 10 numbers from 0 to 9, these are categorized into different types, such as natural numbers. The numbers 1, 2, 3, which we use for counting certain objects, these are called natural numbers, and the other name for these natural numbers are positive integers, because if there is not a directed sign here, plus or negative written, it means that it is plus. It is understood that it is plus. For 1 plus 1 plus 2 plus 3, or you can say these are also positive integers, and these set of natural numbers, these are denoted by capital N. So that is N is equal to 1, 2, 3 up to so on. So this is the pattern for natural number. 1 plus 1 is equal to 2, 2 plus 1 is equal to 3, 3 plus 1 is equal to 4, 4 plus, it means plus 1. This is the pattern for this natural numbers. Second one, whole numbers. If we include 0 in the set of natural numbers, see here, if we include 0 in the set of natural numbers, the resulting set is the set of whole numbers denoted by W. What does it mean? If I introduce 0 in this natural numbers, or if I include 0 in the set of natural numbers, the resulting set is the set of whole numbers, and it is denoted by W. So W, capital W is equal to 0, 1, 2, 3. Now another one, integers. So what are these integers? Are the set of integers consists of positive integers, 0 and negative integers together. Positive integers, 0 and negative integers, and is denoted by Z, that is Z is equal to in between 0. Here on the right hand side there are positive integers, and on the left hand side there are negative integers. So together these positive plus 0 plus negative integers, they fall into the category of integers. Next, there are rational numbers. Now all the numbers of the form P over Q means just like 2 over 3. See, in the fraction 2 over 3, where these P and Q, they are integers. Which integers? This one integers. So this is the condition for rational numbers. All numbers of the form P over Q, where P and Q are integers. Which type of integers are? I mentioned you here. and q is not 0, it means denominator is not equal to 0, and they are called rational numbers. Now this the set of rational numbers is denoted by capital Q. So Q is equal to P over Q. This line means such that P and Q belongs to Z. Z means the set of integers. This Q belongs to Z, and this sign mean and. You can say this is a sign of exponentiation, caret sign, but in while reading this set builder notation form, set the Q is equal to P over Q. P and Q belongs to this sign is for belongs to Z, and Z is the set of integers, and Q is not equal to 0. This is the condition for this rational numbers, and Q is not equal to 0, and this that P and Q is equal to 1. So these are some of the conditions for this rational number. It is a very important numbers you are mainly concerned in your next classes often. Irrational numbers. Now the numbers which cannot be expressed as quotient of integers, which all you can say these are not represented as like this, x is not equal to P over Q. They are not written in the form of fractions or quotient of integers, they are called irrational numbers. So set of rational numbers denoted by Q dash, and here the set of irrational numbers can be written in the set builder form as Q dash is equal to x when this line is for when x is not equal to P over Q, P and Q belongs to Z, and Q is not equal to 0. Now this is the very important MCQ here, the union of the set of rational numbers. You see here the union of set of rational number and irrational number is known as the set of real number, and it is denoted by R. Union of rational number and irrational number, union this union is union of rational number, and you can say the such like this irrational number plus rational number union irrational number, this is equal to a very big set that's called the real numbers. Get it you all till here? Now types of rational number. Okay, we understand what are these rational numbers. Well, now you see what are the types of rational numbers. Number one, suppose if I divide 2 over 5. Suppose I divide 2 over 5 and I find the answer as 0.4, or 3 over 2 is equal to 0.375. Note here that this decimal fraction is terminated here. This decimal fraction is terminated here. It means their division stop till here. The decimal fraction in which there are finite number of digits in its decimal part is called a terminating decimal fraction. For example, I already explained you these two examples in which the division terminate. These are called decimal fractions. Now recurring and non-terminating decimal fractions. So in here the division doesn't stop, it will carry on, it will move and on and on. It's the decimal fraction in which some digits are repeated again and again in the same order in the decimal part is called a recurring decimal fraction. So you hear 2 is repeated, 2 is repeated, 2 is repeated, and here pattern is repeated, 3 6 3 6 3 6 3 6, again next number will be